Hello, this is Josh Hale's assignment 4, heaps assignment, constructing two heaps. So when you open up the zip file, you should just get this, the main and the make file. So if you want to compile it, all you gotta do is type make, and it generates a executable called heaps. So if you do /heaps, it'll then take the two input heaps and then output the combined heap with all of the numbers stacked on top of each other. So if we look at what it looks like, you can also run it by doing make run, so that just compiles and runs it immediately. If we look at the code, this is what a node looks like. I have a value integer, and then I have a value for the right and the left node. And I also have these little void functions to help attach right children and left children, and also assign it the value at the same time. So it it's a lot easier when constructing the heap. So this right here is a recursive function to find the depth of a certain node for making sure which branch is bigger. So like if a branch has a depth of 3, then it has 3. There's a possible root of 3 child nodes underneath it. So obviously that's going to be on the left side for a leftish heap instead of a one of type 1 or 0. So that's what the find depth is used for. It's pretty self-explanatory. In the make leftish, this will take a node that I want to make every node underneath it leftish. And I do this every time I keep grabbing and pushing to the stack. So it sets the right and left depth to 0, and then it compares those depths, and then it will swap those depths and make the one with the larger depth always on the left. So here we have merge heaps, which takes a left and right and then a stack, all references so that they can be used recursively. You can store, so I store the smaller value when I compare the left head and the right head of the two separate heaps, and then I recur it on the right child for that value. So in this case, if the left head is less, then I would push the left head into the memory in the stack, and then I will do the check if it has a right child, and if it does, I'll merge the heaps. If not, then we have found the spot for it to combine the heaps, so this is when all the important stuff happens. So in that case, then I will assign the left heap to the right heap, and then I will create a temporary node to check and see. So ignore this if statement for a second. I will take this temporary node and then figure out all the history from the stack, and then I will make sure that each thing in that, each reference to that position of a node in that stack is made leftish. So that's why I just keep redoing this in this while loop. And if I get to the last two, then that means that I have 2 nodes and 2 separate heaps, and I want the second node to be the parent of the first node in a stack. So that means that the smaller one is going to be the first child, and then I will stack up, and then I will pop, and then I will set the parent to be the top of the next child. And then I will just set the right, because we're always adding to the right, the child to the parent. Then I break, because then I'm done. The function's over. So we're good. And then I will do a stack push. So that's that whole if statement. And I sort of repeat the process in case if the right head value is greater than the left head, then this if statement's run. And it's basically the same thing, except I just switched out left for right. So I'm pushing the value on the right head. I'm pushing the right head, right child, making sure that that exists, and then I merge the heaps for the left head and the right head, the right of the right head instead of the right of the left head, and then I, keep track of the stack. And I do the exact same thing, just making sure that I'm doing this on the right head because I'm editing on the right side. So there you go. Not too. Oh, and then we have the printum that just prints out onto an array format all the values inside of a heap. So the head is going to be, the left head is going to be the head of the combined heap. So you just print the left head at the end. Here's the main, where it takes the left array and the right array, and then it constructs the heap from that. And then after that, you just merge the heap and then just display it at the end. So there you go. All right. Oh, that's not what you do. All right. Well, there you go. Thank you very much for grading my assignment.